So to summarize, we're talking about if you're in 110, 110L, 112, 118, and Maddie 153, which you're going to be in the MPL lab this week. If you're in that, you'll be testing transistors and just, I think, having a lot of fun. Okay. The next semester to graduate on time, 128, 122, 120, well, 100W, and 102, which is like a 17-unit semester. And if that's what you need to do, and you can do it, well, then that's the recommended thing. All right. Yes, banding together in 140 can help. But what I didn't mention to those coming to my office is that this banding idea started right when the pass rate went to 25%. Okay. I feel that the banding people, again, this I don't have proof, but I do look at the grades, and it could be, yeah, that the curve has changed, but I don't know. Okay. So, yeah, I'm not telling you what to do because sometimes some people who could have done it were like, oh, he said don't do it, and then won't. And then some people who shouldn't do it anyway for some reason. All right. So I'm just trying to give you the information and let you decide. I see you. Now I know saying let somebody else decide can sound like, I don't know, has anybody had, oh, wait. Um, has anybody ever said do what you want? What does that really mean? Do what you want at your own peril. I don't have the guts to tell you you're totally, completely wrong or going to flunk, or the bad thing is going to happen. All right. But no, I really sincerely mean it. We're all on the same journey, but our paths are different. They're we're next to each other, but the paths are different. Um, that's for advising time. Because, like I said, everybody's different. It's just this thing of banding, which I just felt like it might just be best just to give you my thoughts on it once and for all. Okay. But your own, like, okay. But thank you for your question. All right. And I tend not to try to talk about other courses, but we're in extraordinary times. All right. Any other questions? Okay. All right. That's a safe question. All right. Area E. Okay. In the fall is going away. Now, if you took engineering 10 here, you already hit your area E. But if you took an engineering 10 and it transferred in as engineering 10, anywhere but here, it'll pop up that you need area E. You don't need area E. Okay, now you want to take it, go for it, right? But your catalog will need to be changed in the fall. So there's paperwork, and so many people are going to want to do this that we're trying to figure out a way to do it all at once because there's a lot of behind the scenes work. Um, Now, yeah, area Ds, you have two Ds, right? There used to be three, and then area F. The thing about Ds is that usually you get your US 1, 2, and 3 along with it, you see. And that's the kind of the tricky part. Now, yeah, and again, it's probably better done in advising, but there's Asian American studies, there's part one and two hits your US governments. African American studies, part one, part two, same deal. Chicano American studies, part one, part two. And then there's political science and history, 15, both with the same number. They hit your D and part one, and you get all your US governments. There is another AMS 10 and 11 might do a C. All right, now, no, I'm not even going to talk about it because I have to write it down. It's that difficult. I can do a Bodie plot from scratch. I can't do GE without looking at it. Okay. Now, the other thing that is going away is you just call it other C. Okay. So you take two C's and then you have to take another one. That's going away. So if you transfer it in and still have some of that lower division paper GE to do, then yeah, you don't need that C. However, if you go back to your community college and finish up your IGETC, and now it's like Cal GETC, it's all one thing. Doesn't matter UC, CSU. I can't believe the words are coming out of my mouth, but the legislature did something pretty good to make life a lot easier for everybody. Okay. Um, Now, yeah, depending on when you came, most of you should need area F, but if your catalog says you need 3Ds, that's what you need. Now, yeah, you switch to the new catalog. Let's say you have all your Ds and you don't need E and C. Well, you're going to need F. Okay. Which, again, it could be a great course to take. Don't get me wrong. I'm just trying to, everything I'm saying is with the regards to just finding the minimum path to graduating, which usually is what people want to know. That's why I just lead with that. Okay. Any questions? It's not like a commentary. Okay. All right. Anything else? 140 is going to be redeveloped over the summer. We're going to have two instructors. So rather than 80 students, it'll be 40-40. Okay. If that helps you make a decision. All righty. So I'm using some prime numbers down here to make, like, every once in a while you get a thing that can't be done. So as I'm making up this example, the big part is that the numerator old is 10s. So yeah, we're going to need to do, and I'm just jumping the gun a little bit, 10s times g of s is going to fix these issues. Okay. All right. And yeah, now be aware, right? Yes, you probably know minus sign is going to lead to poles on the right-hand side. all right? So yeah, that is a reason, but it doesn't show you why, right? Descartes' rule for second order systems is everything has to be there, s squared, s to the 0, and everything has to be the same sign. So it could be minus, 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 or plus, plus, plus. If you violate that, it won't work. However, for third order systems, it doesn't work, much as I found out to my chagrin a long time ago. All right, so, the first bit, right, why? Why is it out of control? You can't just say the minus signs are there, right? Although you use it later as an easy way to fix. You really need the quadratic equation. In this case, B is minus 7. C is minus 51. Okay? And A equals 1, right? Which I think, yeah, having it scaled like this makes it easier. All right? So we have minus minus 7, okay, which right there, it's plus 7. So if I come out here on the number line, I'm going to be here modified by this somewhat, right? But what form will it take? All right, so we have b squared, which is 49. And then we have minus 4. A is 1. And then we have 51. $49 minus minus 51. What do they do? Yeah, yeah. Oh, yeah. That's the bad part. Plus, okay. Dot 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 dot. Well, no. What I was trying to think of, like, all right, do I really need to finish it? Oh, divided by 2a. So this would actually be divided by 2. But what's going on is, right, I have 7, like if this is 0, right, I have 7 plus 7 and 7 minus 7 divided by 2a, right? So if this part is 0, but now it's bigger, right? So I'm basically going to be getting 49 plus something will be, the square root of 49 plus a positive number is going to be bigger than 7, right? So 7 divided by 2. So this one, this term is bigger than 7, so it's going to be somewhere out here, right? And then we have minus something bigger than 7, which puts it here, right? The scale, whatever, but there is one pole on the right-hand side, right? And that means there's going to be some kind of exponential increase. Now, yeah, this is exponentially decaying, but if you look at the form, that you're adding a decaying plus an expanding. So you're not multiplying them together, right? So the shape is just going up exponentially, or it could be negative and going down, right? Now, yeah, just as a quick aside, you see here where I've kind of drawn it linearly, right? Well, if it's an op amp, there's something called a slew rate, and it'll limit your slope. If you try to go any faster faster, it'll go from exponential to linear. So this is actually kind of real. But, you know, saying this, exponential growth, and drawing the little picture answers that part of the question. Okay? And what I'm trying to get across here is you don't actually have to calculate it out. You know what it's going to do. So just think, you're on a job interview, this is out of control, and you're like, well, all right, you probably have to look at the quadratic equation, but then you're like, oh yeah, I'm going to have one root here, right? Now you could just say, well, both of these are, you know, one of at least the sign isn't the same, so we're going to have one, right? At least one. And maybe, you know, that could be good. And then, well, can you tell me why? Oh, well, then you know, it's a conversation, right? If they've invited you in, they actually want to hire you, right? Now, it might not seem that way as they're asking the questions, but it takes a lot of work to screen a lot of resumes to bring people in for a phone. And then once you make it, so they're on your side, actually. Okay. So now we know why it's out of control. And then we got to fix it. All right. We fix it with a simple, bless you, control loop, right? Again, other places might put G up there, right? That's okay. There can be more than one feedback loop, right? But this is our first trip out to control theory. So we're just, then there's this whole matrix thing. Anyway, the transfer function, just as a quick review, would be Q of S, H of S, 1 plus G of S, H of S, right? Now, it's actually better, and I'm just going to leave out the algebraic steps for today. Let's just say the polynomial of the numerator, the old one, right, plus the denominator of the old one, which was the one with the problem, right, plus G of S, numerator S, old. So remember, this is going to fix your issue, but you've got to choose the right G and come up with the right conditions. And this is the issue, right? But really, I just break this up. I substitute H of S, numerator of S, old, denominator of S, old. Let me just say NS. All right. And you just substitute it through, okay? So this one's a little harder, right? Because we have S squared minus, was it 49? No, 7. 7S minus 51. Okay. Now we can say, hey, that minus sign, or I'll just circle, these need to be made positive. Okay. Now, G of S times NS old was 10S, I believe. All right. So now I have to make this positive. I have to make that positive, which, but I have to fix this, right? 10S. Well, just as a preview, right? 10S times a constant can be added to minus 7S, right? But then I need to convert 10S into some kind of constant so I can add it here. So there's actually two things that we need to do. So we can just say fix S to the 1. Okay, that's what we're doing. So we have minus 7S plus G of S times 10 of S. Well, what was the issue? We need to make it positive. All right, not equal to 0. We need to make it positive. All right. Well, what do they call it? You got to add apples to apples and oranges to oranges, right? Well, we have S and S, so that just means that G of S has got to equal K1. Because there's two things, we call it K1 and K2. All right? So now let's just say we have minus 7S plus K1 10S has to be greater, right? Okay. Well, the S's cancel out, right? And K1 has to be greater than 7 divided by 10, right? Because it's already multiplied by 10, right? So if K was 1, oh, it would be bigger than 7, and it would add to a positive number. But we want to know the minimum condition, right? So we have K1 greater than 7 divided by 10, right? Now, yeah, like a trick question, what if there's a minus sign up here, right? Then you got to reverse everything. All right, so just to summarize, K1 has to be greater than, wait, no, 7 divided by 10. All right. But just so we don't forget, GS1 equals K1. Now we have to fix the S to the 0 term, which was minus 51 plus G of S. And yeah, now I'm going to use the word 2, I'm going to say it's 2, right? Times 10S. And we have to make it positive, right? So greater than 0. All right. So here I have S to the 0. Here I have S to the 1. I have to convert S to the 1 to S to the 0. The way that that's done, and again, I'm going to call it K2, is to have the integrator term, right? So now those S's cancel. I have minus 51, and now we have K2 greater than 51 divided by 10. Okay. Now then G of S equals G1 plus G2 equals K1 plus K2S. Let's just see if I can scroll that. Get a little more room. All right, so the new QS 10S, so the numerator doesn't change, right? We have S squared K1 minus 7S plus K2 yeah, no, I have to do it out.
So we changed to a 49.
You got 49 on the brain. Here's the final equation. Here's the two conditions. And to get there, you would have written that down somewhere prior. Okay? So anyway, that completely answers that. Homework 1 is like, oh, plot the poles, control out of control. Homework 2 is, what does it look like in control, out of control? 3 ties it all together with a problem like that.
The homework 3, when it says block the time response, you just want us to say
That sketch. Yeah, don't. Now, of course, in my examples in SymPy, it's plotted out exactly the way it should be. But yeah, no, you're, I know it sounds like, oh, you're prepping for the exam. Exams are baloney. I can't wait to get into the real world. But this is like a real world question, and I want you to do it intuitively. Also, when you're working on the bench and something's not working, you're having to think, all right, what is it doing? Why is it doing it? So I think it is very real world. Okay. I'm going to mix it up a little. I'm going to put a minus sign there. Okay. Now, yep, you can see this is missing, but we don't really know what's going on. The thing is with a little bit of algebra, you can see a pole at zero. And notice, poles at zero are integrators. So this is going to integrate. Oh, does it have other things going on as well? But if you put in a step function, this will continue to rise or fall, right, depending, right? So, you know, now this one, it can help. So I'm just saying there's a pole at zero, which leads to the integrator form. And so a step is like this. Again, it's minus, it might be going down and it might have other things going on, but it will continue to grow. And that's all you have to draw. Yep, like, and I'll just restate the El Capi examples that I do, I plot it out exactly. Because sometimes you're curious, what would it really be, right? But again, it's just not never going, as long as you're putting in a positive value, it will never settle. So that's, but yeah, I mean, to plot it out, one pole at zero. Now, yeah, this is going to be a pole at minus 13. So there's exponential decay, but the integration never goes away. So we have identified where the poles are, we've identified the shape. So if you're seeing something, I put in a step and it's not necessarily exponential, but it's not going down, right? You can figure out, oh yeah, something happened. Okay, what happened? So NS old equals minus 11, right? So GS 11, right? That's the fixed term, right? What are we going to use to fix? Then we have D of S old equals S squared plus 13S. And this is, you know, needs to be fixed. All right. Q of S though, right? Just again, NS old. And this time I'm just going to go straight to it. Okay. N old, denominator old, plus GS and old minus 11 S squared plus 13 S. I'm just going to put like, because it's missing, how, you got to put something there, right? Plus something that's missing minus G of S 11. Okay. So this is what I got to fix, right? And the term is, it's S to the 0, right? It's 11 times S to the 0. And here we have 0 times S to the 0. So what G of S, our choices, right? Proportional, integral, derivative. Which one of those is going to turn 11 into a something times S to the 0? What, what? A?
Or
K, right. So I'm running a little bit out of room here, right? But G of S has got to equal K. All right, so let's do it. S squared plus, oh, sorry. So nothing minus K11 has to be greater than 0, right? That means K has to be less than 0, right? The 11 doesn't really come into it. But that minus sign forces it the other way. Okay. Which you might see on the homework. I try to avoid on an exam because I know what it's like. I might say you should sleep and get exercise the night before, but I can't enforce it. So let's just finish it. Q of S minus 11 S squared plus 13S plus K 11 I'm debating. Yeah, I think it'd be better to be minus. Right, minus K11, right, subject to K less than 0, right? So you put in a number, any negative number, and the poles will be right, and you can do what you will. Any questions on that?
On the exam, do you want us to put like the empty spot, or is it okay if it's all just out? Like, do you want us, we want to see that we recognize that it's empty?
What I would like to see on the exam is the right answer. If that leads to the right answer, then please do it. I'm not gonna take points off for it. But I feel that as I'm talking to you, it's actually, you can see what I'm doing and it's helping me remember, you know. Because, yeah, trying to stand up in front of a crowd and teach something is similar to an exam environment, right? That's why professors will read their notes ahead of time to make sure they're not, going down the wrong path.
So K can be anything less than 0. But if we're changing it from like a really small to a really big K, that's just changing how fast or slow it gets.
Let's see. No, well, it's a good. What was it? 15, 13? 13. K. Okay. So when K equals 0, you're right here, right? But there's another one and it was out at, what did we say? It was minus 13, right? So let's just say K is equal to minus 0.001, right? Okay. Now, it's so small, right, that I can kind of comfortably get away with saying this is here and this one is almost in the same spot, right? But as K increases, these will move to each other, right? To where you will get critically damped, right? 2 poles here, and then it'll keep increasing it, right? And you'll get underdamped, right? And so we have minus 13 plus or minus 13 squared minus 4a 2a minus 4 times minus 11 times minus k, so that ultimately, right, everything, it's still negative, right? Which otherwise it would be out of control. So you have 4 minus 411k. So you can see that when k makes this smaller than that, you're going to get 2 real roots. That's underdamped. When 4 times 11k equals 13 squared, that's here. And then as you keep increasing k, this is going to be bigger than that, you're going to get imaginary. And it does that. So, like, how would this work out in 132? I'm telling you, what are the conditions, fix it, and what are the conditions, and then walk away. 132 will say, with a settling time of this, which you don't know yet, but when you use a phrase settling time, that's a second order system, and usually it's going to be underdamped. So what K will, oops, sorry, you can't see me point. What K will give me the poles here, but it's easier to see in this format. 2 damping omega naught S plus omega naught. So here, omega naught, I'm just going to use minus K 11. Okay, omega naught squared, I should say. So omega naught squared is minus K 11. K's got to be a negative number, otherwise it all falls apart. All right. So that's our omega naught. Then you take the square root of it, and then where these poles are gives you the damping coefficient. All right. Which then, and by settling time, you know, I think it's this one. I have to look that one up. But how long does it take to settle? It's not what I've seen, because I'll look at 132 material to say, what do you need to know? And I'm like, okay, yeah, but you need to know it in 132. What do I need to do to get you ready for it? So that's how that would work, right? You need to make it this. You need to make it that. And yeah, classic, you know, a popular number is to have these separated by 45, which is a damping coefficient. Okay, which is the Butterworth condition, right? Because it rises pretty fast. Only, I mean, what's nice about it is it kind of rises fast, right? And only overshoots once. So it's a great trade-off of how fast do you get there, and then the overshoot you deal with it. Okay. But it could be okay. It's in the specification, right? Um, because having no overshoot for the same system, right, will be slower, right? And now, yeah, if you have this, you're trying to hit a floor on the elevator, right? It goes really fast and it goes over and then comes back, right? Now, if that overshoot, like compared to how far you traveled, was a lot, right? You're gonna like, ugh. And then if it's oscillating, you're like, it comes up and then you're wiggling until it settles out. The thing is you being in the elevator changes the system. So, but a lot of the control system about elevators is people are saying they want to go somewhere and trying to schedule which elevator, go to the library, right? And you'll see it in action. Because there's what, 4 or 5 elevators and 8 floors, or no, 9 because you got the basement, right? Is it 8? Anyway, so you have people randomly choosing where to go, and you have 4 places to get there. So that's scheduling, that is actually an interesting algorithm. Okay, just slap AI on it, and probably got a paper. Although someone's probably already done that. but you can slap it on in a different way. Um, okay. So s to the first is missing, right? But let's put it into the quadratic equation. So we have 0 plus or minus 0 squared minus 4. I should change this to 20. That'd be funny. We'd have 420. Which is Easter. What's you guys laughing at? I don't want that getting out on the internet that I made that joke. Okay. Anyway, but 419. What is it in the Monsters Inc.? I think when they have a human object in the monster world, it's a 2419. And you have to, is it 2419? 2319. Yeah, that sounds funnier.
Okay.
2319. That sounds right. Okay. Anyway, so right away you see that this is minus, we have plus or minus j divided by the square root of something, you know. Sure, divide it by 2. Why not? Right? And there are poles. Now, it's purely imaginary, right? Imaginary things lead to oscillations, right? That's one way to think of it. The other way is if you look on the cheat sheet, you'll see that the inverse of this leads to some kind of cosine or sine, right? And you can just ignore this. So the output is a sine wave, right? It's not settling, it's not in control. Even though and the thing is if you're trying to make a function generator, yeah, you might want to create a sine wave. And you want that. All right. Now I'm going to, Q of S equals NS old plus the denominator old plus the G of S NS old. Okay? S1 term is missing, all right? So we need G of S times S squared. Because everything else is positive, we want to make it positive, right? I'm going to say we just need anything S to the 1. All right, K times S squared doesn't work. SK makes it a third order, right? So really, K divided by S times S squared, right? Gives us that. S drops out, and K just has to be greater than 0. So S squared plus, ultimately, because I really had no thing there, right? KS plus 19 squared, right? And then it just has to be greater than. But yeah, if it's 0, this is going to be different, right? At 0, it starts here. Then as it increases, it's going to bring it off and kind of bring it down on the circle to where you would get squared, and then it would move it that way. But it would start here and go that way. So yeah, a lot of people have a lot of things going on. I know that I'm like made a big stink about being here, and it's not that I'm changing my mind, but there's a lot of things going on with a lot of people. So I'll try to record these videos. As you can see, don't stake your life on it, because and I guess I'll just have to get here earlier, because I don't know what he did and I don't have the ladder. But so on Wednesday we'll start 4A, but I think, yeah, you kind of already started in lab, and so now you really want to know why you were doing what you were doing. All part of the plan. Okay. Anyway, have a good day. Um, hold on.